let's just remember congruent means exactly the same dimensions, essentially. It might be rotated or flipped, but it's essentially the same. And to prove congruent, there are 5 ways of doing it. We can either show that side, 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 that they have the same sides. Side, angle, side, that they have 2 of the same side with an angle equal in between. This is just for triangles, of course. We can show that we've got an angle the same and a side in between and another angle. Or we can show 2 angles are the same with a side after that. And finally, we've got a right angle, hypotenuse, and a side. One to remember is that SA, if you have 2 sides and an angle but not in between, that does not imply congruence. So that's an important one to know. All right, so how are we going to prove that ABE, that's this one here, is congruent to DCE? That's this one here. I meant to do that in a different color. Yes. All right. Now we're shown, it says that E is the midpoint of of AD. So that means that this length is equal to this length. And I think that's going to be our starting point. AE equals ED. Right, next up, it says BCE is an equilateral triangle, so all of these are the same. And that gives us another lot of sides that are the same. Brilliant. So we can say that BE equals EC. So we're well on our way because we've got 2 sides that are the same. Now, can we show that CD is equal to BA? That doesn't seem very easy. The other one we could look for to see that these 2 are the same. And that's going to be our play, basically, because one thing I've not added is that this is 60, this is 60, and this is 60. And furthermore, we've got alternate angles going on. So this is also 60. And we've got a backwards one over here. This is also 60. So I can say that angle AEB equals angle CED, C above, alternate angles. And finally, I just need to make a conclusion. By SAS, triangle ABE is congruent to triangle DCE. You can write it in words, but this is a fancy way of writing congruent in symbols.